Hello people, welcome to this wonderful tutorial, pharmaceutical chemistry and analysis. Let's try to look at this question that came in one of the question papers, and this is no synthesis of pyro. So the reaction is called no synthesis of pyro. Okay, no synthesis of pyro, that is the reaction. Then it is catalyzed by the base. So this is called the base catalyzed reaction. It's not an acid. Okay, so we need to know how to go about this. That is, the question is saying propose a reasonable mechanism for each of the following reactions, and put this, which is just A, that is our subject of today. Let's try to look at the mechanism. So here they're saying propose a reasonable mechanism. So let's try to propose a mechanism that is reasonable. Okay, so if you need to know, is it a base catalyzed or acid catalyzed? So if it's a base catalyzed, have you seen that this is sodium ethanoate? So what we are going to do is we need to write sodium, something like this, and it needs to dissociate into sodium with a positive, and this one, which is ethanoate, like this, with a negative here. You get? So this is a, now we want to show that it has dissociated to give these, and we are going to be using ethanoate as our base. Okay, so the first step that we are going to look at, remember, when you're writing a mechanism, you just go straight. If you have an A3 paper or A1 paper, it can just go in a straight line. But because we don't have a large board or a paper, we are just going to be using to start with the last step that you are going to have with the product will be your first step in the next line. Okay, so here what you're going to do, if it is a base catalyzed, you are not supposed to protonate. There is no protonation. So there is a question where they can say, how does describe how the base catalyze the reaction, or how the base do to the reaction. So a base can catalyze reaction by making a nucleophile, or making a nucleophile or activating a nucleophile by obstructing a hydrogen. Compared, you see, when you look at acid, we are saying it is it activates the electrophile by protonation. So here this is a base catalyzed reaction. So what we are going to do is to make the enolate, or to make the nucleophile by obstructing the hydrogen. So under base catalyzed reaction, we are going to start with this. So here I'm going to get this. So here I said is to make a nucleophile by obstructing the hydrogen. That's why here I've put this hydrogen alone and 2, because there are 3 hydrogens. So to make the reason why I put this as alone, or to expose this hydrogen for the easy attack. Then here I'm going to say I'm going to bring this ethanoate, which is the base, like this. Get? So here I'm going to grab this hydrogen, then this bond will come, these electrons will come direct to the carbon. What I'm going to have is this. So here I'm sure you can see what I'm going to have is with a negative here, then here CH3, like this, you see, then plus, because I've gotten the hydrogen, I'm going to have something like this. You get? But when I get this hydrogen, I extract this hydrogen, I grab this hydrogen, the electrons will come direct to the carbon, and it will be a negative like this. These are the products that we have there. Then the next step is to make to make this. This is a nucleophile which I've made. It will attack this which is I can write it like this. You've seen that this is which is called 2-amino cyclohexanol. So this is the one that we are going to use there, which is then have you seen that this nitrogen is down there? So you can just orient it to say it's the same as this. So this can be like this, then here like this. So it's the correct thing. I've just oriented it, or I've just moved it clockwise rotation, that is like this. Then I'm going to bring this, which is with a negative here, then here something like this. It's the same thing like that. So this negative will come and attack where the carbon that bears a carbonyl, on the carbonyl, in short, that bears an oxygen, that one, which is like this. So this one will open like that. Then I'm going to have the product, which is so this one, it attacks this carbon, this one will open. Then I'm going to have something like this. Since it has opened, it will be negative like that. Then here it will be like this. This is SH2, which is it's CH2. This is CH2 here, which is here. Then here it will be like this. Okay, something like that. That's where we are now. So there, what we are going to do is this, which is the compound that we have as a product. On the nitrogen, it has got lone pairs here, which are these electrons, lone pair of electrons. So here we're going to say these electrons will come and attack on the carbon that has oxygen there. So this one will open as well. So what we are going to do, we're going to have this product as something like this. So here, okay, I can have something like this. So here we have how many hydrogen? 2 hydrogen. Then here we have CH3 like this. Then here with a positive on the nitrogen, we have a positive, because now it is having 4 bonds. So what we are going to do, we are going to say this one, which has opened like this with a negative like that, since it is a base catalyzed reaction, this one can come and grab this hydrogen. That's what we call intramolecular attack. So here we are going to say this, when it grabs this hydrogen, this bond will come and neutralize the charge like that. You've seen? I think we are following. So what we are going to have, we are going to have something like this. Okay, we're going to have something like this. So we have only one hydrogen there, then CH3, then here we have OH. So what you need to do here, we can say, remember what we have there is this, which is an acid there, hydrogen, because we have added the proton there. So here we can make we can get the same one, which is like this, and grab this hydrogen, then this bond will come here. So what we are going to have, we are going to say, or the electrons will come there, yeah. So here we're going to have this, okay, OH like this, CH3, then here we have OH like this. So what we want to eliminate the OH now. It's base catalyzed reaction, OH can leave. Not on using the acid catalyzed reaction, the OH will be left as a a bad leaving group. So what we are going to do is we are going to say here you can start with any. For example, if I say no, let me just remove that one, I'm going to expose this hydrogen here. For me to remove this, I'm going to expose this hydrogen there to attack and make a bond which is inside there to remove this. So what am I going to do? I'm going to bring this ethanoate which I've formed here because I've grabbed the hydrogen. So here it will come and grab this hydrogen, or to obstruct this hydrogen. This bond will come and make a double bond or a pi bond there. What will happen to this? This one will go like this. You get? So all the electrons or the bond will break and all the electrons come to the oxygen. So there I'm going to show it like this. So here what I'm having now is that I'm having this, which is H, something like this. You've seen that what I'm having, and the one that has been removed, which is the OH there. So I'm having this product, which is like this. Here there's a bond, then here there's CH3, then here there's OH. So you may ask, which one are we going to use for us to grab this hydrogen which is here, for us to obstruct this hydrogen and make a bond inside to remove this OH there. Since here we have removed this OH there, so we are going to get the OH. Yeah, we're going to get this OH, which is which is the one that has been removed from there. So I'm going to bring it and grab this hydrogen, then this bond will make a double bond there. What will happen to that? This bond will break and all the electrons will come to the oxygen. So this one also is going to leave. So what we are going to have is the final product, that is so it's the final product, which is like this. So here there's a bond, even here there's a bond, here there's CH3 like that. So that is the final product, that is called a derivative of pyro. So you've seen where we came from and where we are now. That is the base catalyzed reaction. You can use sodium hydroxide if you want. If the question there is sodium hydroxide, you can use sodium hydroxide. If there is sodium ethanol, use that one. That is the base that you have been given, but that's how you go about the base catalyzed reaction. So that's how you move. So if it's your first time to watch this video or these videos that I'm sending, that I'm posting, please subscribe, and don't forget to leave a like or a comment. Thank you so much, guys.